Today's lesson is on chords and inscribed angles. Okay, now let's learn about chords. What is a chord? A chord is a line segment whose endpoints are on a circle. For instance, here we have a circle. I'm going to draw a chord. So here's a chord that I've drawn. I'm going to name it AB, so it has endpoints AB, and I'm going to put a point C somewhere on the circle. This line segment that cuts through the circle, this is called a chord. So AB is a chord. Now notice that AB creates an arc. So here, you see this arc here? That's arc AB, and that is a minor arc. And notice that there's an arc here as well. ACB, that would be the major arc. Okay, now let's talk about the perpendicular chord bisector theorem. The theorem reads, if a diameter is perpendicular to a chord, then it bisects the chord and the arc created by the chord. Notice here, BD is a diameter and AC is a chord. So this BD, not only does it touch this chord AC at 90 degrees, it also bisects it. Now what does that mean to bisects? It cuts it equally into half. So what we can say is, because it does that, we can say that AE and EC are congruent. Now we can also say that AB and BC are also congruent. Respectively, we can say that AD and DC are also congruent because this diameter cuts everything into half. Okay, let's take what we learned and apply it to example 1. Example 1 says, find the measure of the following. Arc LM, line segment OM, OM happens to be a chord, and line segment LN, which happens to be the diameter. Now let's take a look at the figure. Here it says we need to find arc LM. This is arc LM. Now what do we know? We know that this cuts this arc into half. Now if it cuts into half, then that means that these two sides are congruent. So arc LM and LO would be the same value. So LM is equal to 27. Now let's take a look at the next one, OM. What would OM be? OM is this chord here. Now we see that PM here is 39. So if PM is 39, then OM would be double 39, and that would be 78. Finally, let's take a look at LN. LN is the whole diameter. You see that? Now if the radius is 45, which is halfway, then double this thing would be 90. Okay? Now, that's how you solve it. Now let's try number 1. Try this one on your own. I'll give you about a minute and we'll go over it together. Okay, that should have been enough time. So let's go ahead and take a look at it. So it says here UVT. UVT is this arc here. Well, if half the arc is 33, then UVT, the whole thing, would be 66. Next, it says find VS. VS is the full diameter. If half the diameter, which is the radius, is 21, the full diameter would be 42. Finally, WU. WU is half the chord. And WU would be congruent to WT. So WU would be 17. And there you go. Now let's apply the perpendicular chord bisector theorem to example 2. Example 2 says, solve for x and find the measure of PT. So first thing, let's take a look at our figure. And if you see, again, this diameter cuts this chord into two equal parts. So we can say that this side and this side are equal to each other. So we could set it up as an equation. And I generally like to put the bigger value x on the left side to come out with a positive x value, because it makes it easier to solve. So let's take a look at how I set it up. 7x minus 2 is equal to 3x plus 26. Now, I'm going to subtract 3x from both sides, cancel it out, and let's take a look at it. 7x minus 3x, that gives you 4x. Drop the negative 2, drop the equal sign, drop the 26. Next, we got to get rid of the negative 2. And how do we get rid of negative 2? We're going to add 2 to both sides. So let's go ahead and do that. Plus 2 plus 2. That negative 2 and positive 2 cancel each other out. Drop the 4x, the equal sign, and 26 plus 2 is 28. Now we have 4x equals 28. Get rid of that 4. And how do you get rid of a multiply by 4? You divide by 4. Cancel that out. That gives you x equals 7. 28 divided by 4 is 7. Now, that solves for x, but we're not done yet. We need to find the value of PT. And the value of PT is, well, PT, if you take a look, is equal to 3x plus 26. So we're going to have to substitute. So right there is going to be 3 times 7 plus 26. 3 times 7 is 21. 21 plus 26, and that is 47. And there you go. So let's go ahead and take a look at try 2. And it says solve for x and find the measure of HD. Okay. You can pause the video, because I'm going to give an explanation. So go ahead and pause the video. And when you start it back up, you'll have the explanation. Okay, let's take a look. If you take a look at the figure, again, we have EG, which bisects this chord here. And so that means that these two are equal to each other. So if these two are equal to each other, we can say 9x minus 3 is equal to 4x plus 42. Now, what do? We need to bring the 4x to the other side. So we're going to subtract 4x, cancel out the positive negative 4x. 9x minus 4x gives us 5x. Drop the negative 3, drop the equal sign, and drop the 42. So now you have 5x minus 3 equals 42. What's next? Next, we're going to get rid of the negative 3. So to get rid of a negative 3, you add 3 to both sides. So plus 3 here, plus 3 here. Cancel out the negative and positive 3. Drop the 5x, drop the equal sign, and 42 plus 3, which is 45. So now we have 5x equals 45. Let's get rid of the 5. Divide by 5 on both sides. So now you have x equals 45 divided by 5, which is x equals 9. Now let's substitute it back into HD, and let's take a look. HD is equal to 4x plus 42. So let's substitute. 4 times 9 plus 42. 4 times 9 is 36. 36 plus 42, add them up, and you get 78. So HD is equal to 78, and there you go. Now let's apply it again to example number 3. This time, it's referring to arcs. So it says solve for x and find the measure of arc BC. Again, let's go ahead and take a look at our figure, and you see that here this diameter BD cuts this arc into 2 equal parts. So we can say that these two are equal again. So 10x minus 5 is equal to 4x plus 13. Now to solve this, we have to get rid of the 4x and bring it to the other side. So we're going to subtract 4x from this side and subtract 4x from this side. Cancel that out. 10x minus 4x is 6x. Drop the negative 5, drop the equal sign, and drop the positive 13. Now we have 6x minus 5 equals 13. What next? Well, we have to get rid of the negative 5. And how do we do that? We're going to add 5 underneath there and add 5 to the 13. That cancels out the 5's. Drop the 6x, drop the equal sign, and 13 plus 5 is 18. We have 6x equals 18. How do we get rid of the 6? We're going to divide by 6 on both sides. Cancel out the 6, and x equals 18 divided by 6, which is x equals 3. Now, it asks for us to find the measure of BC. So let's take a look at BC. BC, if you take a look, arc BC is equal to 10x minus 5. So let's substitute. 10 times 3 minus 5, which is 30 minus 5. So arc BC is 25 degrees. And there you go. Now it's your turn to try number 3. It says solve for x and find the measure of KL. Now you might want to pause and start over. If you take a look, again, we can say that those two are equal to each other. So we can say 11x minus 5 is equal to 8x plus 22. Minus 8x from both sides. Let's go ahead and do that. Cancel it out. 11x minus 8x, 3x. Drop the negative 5. Drop the equal sign. Drop the 22. Now we have 3x minus 5 equals 22. So to get rid of that negative 5, we have to add 5 to both sides. So I'm going to do that. 3x equals 22 plus 5, which is 27. Now we got to get rid of 3. So we're going to divide by 3 on both sides. Cancel that out. And x equals 27 divided by 3, which is 9. So x equals 9. And we still have to find the measure of KL. And if you take a look, KL is equal to 8x plus 22. So let's substitute. KL is equal to 8 times 9 plus 22. 8 times 9 is 72. 72 plus 22 is 94 degrees. And there you go. Next, let's talk about inscribed angles. So what is an inscribed angle? An inscribed angle is an angle formed by two chords inside of a circle. So let's take a look at that. So you see, I drew two chords inside of a circle, and it created an angle. That angle is angle ABC. So angle ABC is an inscribed angle. Now notice what it does. This angle touches a circle and creates an arc. That arc is known as the intercepted arc. It is an arc created by the inscribed angle. And that intercepted arc would be arc AC. So AC is the intercepted arc. Now, let's learn about the inscribed angle theorem. The inscribed angle theorem says the measure of the inscribed angle is half the intercepted arc. So, let's take a look at this. So, this angle here is the measure of the arc. Well, this angle here, angle ABC or angle B, is going to be half this angle. So we can say ABC is half arc AC. Let's apply the inscribed angle theorem to example 4. Example 4 says, find the measure of angle RST. So we're trying to find the measure of this angle here. Well, what do we know? We know that RT is what? RT is 72. Okay? We know that this is 72, so this will be half of 72. So we can say angle RST is equal to half of 72, which is 36 degrees. And it's that simple. Okay, given that, let's try number 4 and find the measure of WXY. Take a look at that figure and find the measure of WXY. I'll give you a second. Okay. All right, so we see here that WY is 154. WXY will be half that value. So we can say angle WXY is equal to half of 154, which is 77 degrees. And that is it. Okay, now let's apply the same theorem on a different variation. It says, example 5 says, find the measure of the following. Arc KM. Let's take a look at the figure. Here we have to find arc KM. Well, what do we know? We know that the inscribed angle is half the measure of the intercepted arc. Well, this time we have it in reverse, so the intercepted arc is going to be double the inscribed angle. So in order to find arc KM, we say arc KM is 2 times 19, which is 38 degrees. With that, let's try number 5. Number 5 says find the measure of arc DF. And again, same thing. What do you think is going to happen? That's right. Arc DF is double the value of the inscribed angle. So arc DF is equal to 2 times 65, which is 130 degrees. Now finally, let's take a look at example 6. Example 6 says find the measure of the following, angle B. This is a little bit more complicated, so let's take a look at what we have. We have here, notice what we have. We have a circle and we have a quadrilateral inside of a circle. We're given the values of arc AB and the values of arc BC. We're given the value of angle A, which is 115, and the value of angle C, which is 63. So how do we solve this? Well, let's take a look. What I know is that if I add these two together will equal the arc intercepted by angle D. So let's go ahead and do that. So we're going to take arc addition postulate, and we're going to add these two arcs together to give us ABC. So here, AB is 64 plus BC, which is 112. That gives us 176. Now, this arc here is 176, so we know that D is going to be half of that. So D is half of 176. D is 88. So we can say D is 88. Now what's next? Well, we know that since this is a quadrilateral, that the inside measures of a quadrilateral is 360 degrees. So we can say angle B plus 15 plus 88 plus 63 equals 360. Let's go ahead and add it up. Angle B plus 266 equals 360. Now let's get rid of the 266, minus 266 from both sides. So angle B equals 94 degrees. And that's how that is done. Now with that, let's go ahead and try number 6. Find the measure of angle N. Again, let's take a look at it. What do we know? So again, we have a quadrilateral inside of a circle. We know the measure of arc KN, which is 57. The measure of arc NM, which is 121. The measure of angle M, which is 81, and the measure of angle K, which is 94. Well, first of all, we know that this here, we can use angle addition to find K and M. So let's go and do that. K and M, we add 57 plus 121. That gives us 178. So if this arc is 178, which is intersected by this inscribed angle L, L would be half of 178, which is 89. So if this is 89, again, we know that if I add all these together, then it equals 360. Let's go ahead and do that. Angle N plus 94 plus 89 plus 81 equals 360. Okay, now let's go ahead and combine these terms. So angle N plus 264 equals 360. Get rid of the 264, minus 264 from both sides. Cancel it out. Angle N is equal to 96, and there you go. And that is how it's done.